All right, good afternoon, everyone. Here we are with another science lesson. Today's topic is how water changes state. So all week we've been talking about the hydrosphere and all the water on Earth. And yesterday we dove into the water cycle and talked about all the ways that water is transforming on Earth all the time, every day. So that's what we're going to talk about today. Here's our objective. I can describe how water changes states of matter. Sweet. So you guys probably remember, if you've been with me all year, that we've talked a lot about matter and the states of matter, right? So remember that everything around us is made of matter, right? Matter is anything that has mass and takes up space, right? Has mass and volume. So everything that you can touch and almost everything that you can see is made of matter. It's made of little tiny atoms, right? Including water, which we remember is made of H2O, right? 2 hydrogens and 1 oxygen. Let me see if I can get rid of this. There we go. Oop. So first question, see if you can remember. There we go. See if you can remember, what are the 3 states of matter? Right? We've talked about it quite a lot, so see if you can remember, what are the 3 states of matter? And here is your hint to start you off. Remember that matter only changes when you change the amount of energy in it, right? So these molecules are all the same molecules. The only difference between them is how close together they are, how fast they're moving, right? How much energy do they have? So there's your hint. Now is your chance to pause the video. First question on your during class Google form. Okay, on that during class is what it's called, the Google form. So go to question number 1, what are the 3 states of matter? Okay, and once you've answered that question, obviously you press play on the video, and hopefully you answered solid, liquid, and gas. We also learned about the 4th state of matter, plasma, but we're not going to talk about that today because water does not become plasma very easily. So we're mostly focused on the hydrosphere and how water is changing states on Earth in our hydrosphere. Right? So it's most common that water is going to be in the form of solid or liquid or gas on Earth, not in the state of plasma. So don't forget, the 4th state of matter is plasma. Okay, but today we're going to focus on solid, liquid, and gas. So most of the water in the hydrosphere is in liquid form, right? In lakes, in rivers, in the ocean, obviously, which is where we find 97% of the water in the hydrosphere. So most of the water is in liquid form, but remember, not all water in the hydrosphere is in liquid form. There's also solid water, which we usually call ice, and water vapor, which we call steam or just water as a gas, right? So solid water and water vapor are also important parts of the hydrosphere. There's our little water molecule, cutie. So remember, anything that's made of H2O, anything that has those water molecules is part of our hydrosphere, okay? Anything that's mostly water. All right, so now is another chance to pause your video, pause, and answer question number 2 and number 3 on your Google form. Question number 2, where can you find solid water on Earth? Where do we find solid water? In nature, out in nature, where am I going to find solid water? And then number 3, where can you find water vapor on Earth? Okay. And when you're ready, press play, and we're moving on. Here we go. Oops. Yesterday, we learned about the water cycle. So let's quickly review how water is changing in the hydrosphere through the water cycle. Okay, so here is a quick picture. I love this 3D image of the water cycle. We can see water evaporating from the heat of the sun. We can see water transpiring from plants, right? Condensing into clouds and then turning back into rain. That's what we call precipitation. Okay, it comes down the mountain, either in a river or as runoff, gets collected in pools and lakes and ponds, and then it infiltrates or percolates or gets absorbed into the ground, right? And this whole process, remember we talked yesterday about how this whole process is simultaneous, right? It's not just one thing leading to the next. It's all happening all at the same time, right? Evaporation is happening at the same time as precipitation, and all the water cycle is all happening at once. Okay, here's another good image of our water cycle. Okay, so let's just go through the stages really quick. This image that we see obviously is the sun heating up liquid water, turning it into water vapor, allowing that water to go into the atmosphere. We call that evaporation. Once that water vapor gets high into the atmosphere and then it cools off, it starts turning back into those water droplets, back into liquid water, and that's what forms clouds. So you guys probably remember condensation. Condensation forms clouds. Okay, and then what's the next step? After that cloud gets heavy enough and full of enough water droplets, eventually those water droplets are going to fall back to the ground, fall from the sky, and what do we call that? Boom! Pause the video. Ding! I should have some kind of bell or some kind of sound for every time we pause. That would be nice. So question number 4, go to your Google form during class, Google form, and go to question number 4. What do we call rain, sleet, snow, and hail? What is that stage of the water cycle? Okay, and we're back, and the answer is precipitation. Precipitation. So even if it is solid water falling from the sky, if you have water going from the sky to the ground, that's precipitation, right? As rain, sleet, snow, or hail. Sweet. And then some other stages of the water cycle we talked about were transpiration. Remember, that's when water vapor is released from plants. Percolation, which is when water sinks into the ground, gets absorbed by the soil. Sometimes we call it absorption or infiltration. You might hear people call it infiltration. So absorption, percolation, infiltration, that's when water's soaking into the ground. And then we also have collection or accumulation, right? That's when water finally gets to one place and it gathers all up in one place. So either in a lake or in the ocean or in a pond or even in a river, that's called collection. When water's not really on the move, it's sort of stored in a place. Okay, sweet. So there we have it. That's the water cycle that we learned yesterday. And the reason I'm going over it in such detail again today is because it really is still relevant to our topic of discussion, which is how water changes state, right? So even as water's going through the water cycle, from evaporation to condensation to precipitation, as water's going through all of these stages, it's changing from state to state. Sometimes from liquid to gas, sometimes from liquid to solid, sometimes from gas back to liquid, right? It's changing through all of the states as it goes through this cycle. So there you go. Matter is constantly changing states. So when matter is changing states, it really depends on how much energy is in or is being added or subtracted from that state of matter, right, from the water. So you can either add energy and it will change from solid to liquid to gas, or you can remove energy and it'll go back the other way from gas to liquid to solid. So do you see these arrows changing? We're either adding energy or removing energy, going back the other way. Okay, so evaporation is when we go from liquid to gas. That's adding energy to the liquid. So pause your video and answer question number 5 on your Google form. As a liquid gains energy, what happens to it? As a liquid gains a ton of energy, what happens to it? Okay, and then you should have written something along the lines of liquid turns into gas. When you add a bunch of energy to a liquid, those molecules start moving faster and faster. They start spreading further out, right? You see these molecules of gas that are starting to flee and leave their perimeter because they're gaining a bunch of energy. So they're moving faster and they're spreading farther apart. And that's what makes it a gas. Okay, so that's what's happening with evaporation with the heat of the sun. It's changing that liquid and transforming it. The molecules themselves are staying the same, right? It's still water. They're still little water molecules. They're just changing how much energy they have, changing what form or state they're in. Okay, and then you have the opposite. Notice the arrow changing from one direction to the other. So condensation is just the reverse. It's just the opposite of evaporation. Condensation is when that water vapor gets cool enough, right? This gas starts cooling down, which means the molecules are moving slower and they're coming closer back together. Think back, students, if you've been with me for a while, new students, you might not remember this reference, but students who have been in my class, think back to when we talked about those different concerts, right? Our winter concert, that's the solid. Our springtime concert, where we're a little bit loosey-goosey, that's our liquid. And then summertime concert, when we're running all around the room and spreading all the way out, that's our gas, right? So as we go from a gas back to a liquid, we're just coming closer together, lowering our energy a little, and cooling down. Okay, so that's condensation. All right, and then we have freezing, something we're all familiar with. If you've ever eaten ice cream or a popsicle, you know you had to put it in your freezer. That juicy popsicle started out as a liquid, and then once it lost a bunch of energy, it turned back into a solid. Okay, so you can see in the liquid, the molecules are all loosey-goosey. They're not trapped in one place, right? They're not super, super tight. And if I were to draw it, I would probably draw it with a little bit more space between the molecules too, because they're kind of spread out, right? They have a little bit of wiggle room. And then once they freeze back into a solid, they get so close together and so tight, or in the case of ice, right, they turn into that crystal structure so that they're not really moving very much, right? They're kind of stuck in place. So that's freezing, when liquid loses enough energy that all of those molecules can just slow down and basically crystallize and harden into place. This happens, and this is important because this will be on your DOL, this happens for water at a specific temperature. Okay, there's a point when liquid water will freeze into solid water. Okay, it's actually the same temperature where solid water, ice, will melt into liquid, right? So we call this the melting or freezing point of liquid, of water, not of liquid, of water. So the melting or freezing point of water is 0 degrees Celsius or 32 degrees Fahrenheit. So we've talked before about the difference between Celsius and Fahrenheit. They're just two different scales that we can use to measure temperature. Right? So normally in the United States, we use Fahrenheit, right? So when people say, oh, it's such a nice day, it's 70 degrees outside, that's Fahrenheit temperature, right? So 32 degrees is the point. Okay, and it's not super, super exact. There's a little bit of a range there, but right around 32 degrees, that's the point when this crystal structure, this solid structure of water molecules starts to break down. And those molecules they're warm enough at 32 degrees that they can start to wiggle around and move and melt into liquid form, right? It's also, as it's getting colder, that's the point when liquid water will start to harden into this crystal structure, right? So polymer pause your video, go to your Google form, and answer question number 6 for me. As a liquid loses energy, what happens to it? So as this liquid loses enough energy that it hits 32 degrees, what happens to it? Okay, and hopefully you told me it becomes a solid. Right? As liquid loses energy, you could say it freezes, or you could say it becomes a solid. Awesome. Okay, and then melting is just the opposite of freezing, right? So notice how our arrows are going back and forth. This arrow is facing from liquid to solid. And then with melting, it's the opposite direction, from solid to liquid. Right? It still is the same exact point. So the melting and freezing point are the same, this 32 degrees right here. That's the same point when, it's like the boundary line, right, between the solid and the liquid. That's the point where solid will either turn to liquid if it's warming up, or if it's cooling down, that's the point where liquid will turn into solid. Okay, so we're at question number 7. What is the melting, freezing point of water? Pause your video, go to your Google form, and answer question number 7 for me. Alrighty, and that answer is 32 degrees. 32 degrees Fahrenheit, or 0 degrees Celsius. 32 degrees Fahrenheit, 0 degrees Celsius. That will be on your DOL, so if you're not taking notes, I suggest you start writing that down. That would probably be helpful for you. Okay, so just to recap, we're just about finished with the lesson, but let's go over what we learned today. Water changes states of matter depending on how much energy it has. Right? So remember, those molecules are still molecules of H2O. They're still water molecules. They just change from solid to liquid to gas depending how much energy they have. So how close together they are and how fast they're moving. So higher energy equals higher temperature. And that means your molecules are moving faster and they're more spread out. Right? So your molecules are starting to expand away from each other. So that's like when you go from a solid to a liquid, which is melting, or from liquid to gas, which is evaporation. That's when you're adding energy, right? Molecules are spreading out and moving faster. And then lower energy means lower temperature, right? So that means your molecules, if we go the other direction on the scale, that means your molecules are moving slower and they're moving closer together. So that's like when we go this direction, notice the arrow is facing from gas back to liquid and liquid back to solid. So condensation, when gas turns to liquid, and freezing, when liquid turns to solid. Okay, so you can see from here over to here, your molecules are turning from, they're really spread out in the beginning, and then they're slowly getting closer together, and they're moving less and less until they're finally in solid crystalline form. Okay, so the hydrosphere is constantly changing. All throughout the water cycle, water is changing states from solid to liquid to gas and back again. And remember, this is happening all the time. It's not like one day water is changing from liquid to gas and the next day it's changing from liquid to solid. Nope, all over the earth it's going through these changes all the time. So I believe that's our last slide. Yep, that is the end. So now it is time, my dears and darlings, to go back to your Google Classroom. I believe there was just one YouTube video to watch today, so you can go and take your DOL. go back to Google Classroom and click on the DOL link, and then make sure you view your score after you take DOL so that you can see what level of LSAE work to work on today. Okay, if you have any questions, reach out to me, send me a message, or pop into our video chat, which should be happening right now as you're watching this video, if you're watching it during the afternoon anyway. And if it is not time for a video chat, then you can send me a message or send me an email, and I will help you if I can. Okay, have a good day. See you later.